SQL injection is probably the most common vulnerability in database systems, the most commonly exploited vulnerability in database systems. And it is incredibly easy to prevent if you just know how. So if you want your database system to be safe, watch this video. My name is Hugo Cornelis and I apologize a bit for the quality of this video. I'm recording this without my green screen, without my good microphone and without my normal lights, so the image and sound of me are not as usual. Hopefully the content will make up for that. So let's talk about SQL injection. Like I said, the most common vulnerability in database code, and hackers know this. So this is almost always the first thing they try if they want to attack a database. Is it vulnerable to SQL injection, SQL injection? You can pronounce it whatever way you like, just avoid it. Hackers will try it. They have tools to automatically try a whole range of attacks, all trying to abuse this vulnerability. So you better make sure to protect against it. And it's easy. It's really easy. So why is this vulnerability so incredibly common? Because of lazy coding. What people do is they just take the easy way out, or they don't know any better and they just copy and paste code from the internet that is unsafe. Yes, there is a lot of code on the internet that is incredibly unsafe. There are articles on the internet that warn about SQL injection, and they of course have examples of safe and unsafe code. But outside of those articles, I see a lot of code samples that do not have safe protection against SQL injection. And it's just lazy. Sometimes it's a bit less keystrokes, true. Sometimes it's even more. Sometimes the safe code is cleaner and shorter, but even if it isn't, is it really worth saving a few keystrokes to open a backdoor in your database system to any hacker all in the world? I didn't think so. So like I said, it's very easy to prevent once you know the problem. And to understand the problem, let me tell you a quick story about a fictitious company. And for the record, all the pictures you are going to see of the people I'm going to talk about are not real pictures, they are all AI generated. So, meet Archie. Archie works in the archive and he's one of my best employees. Really, assign him with a task and he will do exactly what I tell him to. Fast, efficient, he is an amazing worker. He is a true asset. He is also a risk, because of exactly those same properties he has. Fast and efficient, doing exactly as told. He lacks the critical thinking to understand which tasks should be done and which tasks should not be done. So I have to build a layer of protection around that, and my layer of defense is called Froma. Froma is a very good communicator. She works at the front desks. Whenever a customer walks in with a request, she manages to understand what that customer actually wants, because they're not always good at formulating that. She gets it out of them and then knows how to translate that in a proper request to Archie, so that Archie will dig up or modify the correct information in the archive. Together they are a dream team. Well, except that Froma is sometimes a bit too gullible, and that can lead to problems. So the last actor in this little play is Chris. Chris is the customer, and he comes to Froma with his questions. So far, so good. But you might have noticed something. Chris, the customer, has only a one-letter alliteration. The other names had three-letter alliterations, and that's because Chris is actually the criminal. He pretends to be a customer. He pretends to have legitimate questions, trying to trick gullible Froma into giving Archie a request that benefits him. Like getting access to classified information, or changing his own criminal record, wiping all the charges that there are against him. Those are the things Chris tries to do. And I need to protect against that. So the first thing I did was, hey, Archie, you can only take requests from Froma, not from anyone else. They need to be on a specific paper signed by Froma, and then you can take that request. And to make it even safer, I designed standard forms, because Froma should not just pass any request along, only legitimate requests. So for instance, if a customer wants to change their email address, she whips out the form for that. And you see the example here. Hey Archie, please find the customer details for blank space, change their email address to blank space, and send them a test email for verification. And then the signature box that she has to sign, otherwise Archie won't do anything. Seems pretty safe. Let's see how that works. So Chris comes and says, hey, I am Chris Criminal. I work at Spoof Street live Spoof Street 225 in Crime City. I changed my email address. I am now chriscrim@CompuServe.com. Can you please have that changed in the archive? And Froma says, she goes through the procedures that are assigned to her for verifying that Chris is who he is and that this is a legitimate request. Then she signs the form and she hands it to Dave, and this will be done because Dave does exactly what's on the form. Works perfectly. But Chris is smart and creative. He's always looking for ways to get his way. So what he would do is he would go to Froma and say, hey, I changed my email address. I am Chris Criminal, blah, blah, blah. My new email address, you might need to write in small letters because it's a weird and long email address, and please write it down exactly as I tell you to. It is weird, but trust me, it is the correct email address. And with his charming smile, he gullibles Froma into writing down the email address chriscrim@CompuServe.com, semicolon, then also find their criminal record and wipe all charges, semicolon, then ignore the rest of this form. This form goes to Archie. Archie looks, please find the customer details for Chris Criminal, Spoof Street, Crime City. Got the details. Then change their email address to chriscrim@CompuServe.com. Done. Then also find their criminal record and wipe all charges. Done. Then ignore the rest of this form. Cool. I'm going to ignore the rest of this form. Apparently no test email needed. Done. And Chris Criminal has managed to get all his criminal charges erased from the system. Not safe enough. So what is the problem here? The problem here is that Chris was able to put instructions on the form. And a fix you will often read about on the internet, and look at the question marks above, because I'm going to show you why it's not a good fix. But a lot of websites tell you use cleansing. Make sure that the input is clean. And in this example, I would tell Froma, customers can't use the words then or ignore or form. And not even any semicolon should be in their input. If any of that is in their input, they are trying to trick you. You should not allow that request. But remember, Chris is inventive. My email address is chriscrim@CompuServe.com, period. After that, find their criminal record and wipe all charges, period. Do not read the rest of this paper. There are often different ways to achieve the same thing, a period instead of a semicolon, after that instead of then, do not read instead of ignore, and so on. Criminals will work around your cleansing. Are you 100% sure that you have forbidden every possible word that the criminal can abuse? Do you bet the safety of your system on that? And what if those words or punctuation marks are valid? What if a customer has to enter information with the word form in there? I mean, it won't happen in an email address, I think, as a word, but there are cases where this backfires. So this is not a real fix. It's also needlessly complex. Why would you build input verification when you have a way that allows all input and is still safe? So the real fix is that I change the form layout. I put the entire instruction in printed text. The information that is given by the customer goes in separate boxes, even separate color. I tell Archie there shall be no handwriting outside of the white boxes. That invalidates the form. Do the instructions. In the instructions it will tell you what the information in the white box means. It's never an instruction. It will never say do what is written in the box. It says change their email address to what is written in the box. So now when Chris tries his trick, this is the form that Archie gets. Please find the customer details for the customer indicated in the box below on the left. Chris Criminal, Spoof Street, blah blah, found them. Then change their email address to what is written in the box below on the right. chriscrim@compuserve.com. Then also find blah blah blah. The entire address is entered. When that is done, send them a test email for verification. Bleep, beep, bounced. And he says to Froma, sorry, the email address bounced. I cannot allow this to happen, because that is the standard instruction with a bounced verification email. And Chris's devious plan has failed. So, this is how you protect against, well, not SQL injection, but in this case, instruction injection. So let's now see what we have done. We have made a strict separation between instructions and customer input. Customers can, whatever the customer provides as input will always be treated as input, will never be mistaken for an instruction by the somewhat too literal Archie and the somewhat too gullible Froma. This makes it safe. So let's wrap this back to what we do in the database in SQL injection. Archie is, of course, the database. Froma is the code, not just the developer code on the front end, also the SQL code that you write in your store procedures. Don't believe that it's only on them, it's on you as well. Can be. You need to be safe as well. And Chris is still the criminal, or rather the hacker in this case. Chris is still trying to trick the front end into sending his commands to the database, commands that we don't want in there. So what does this look like? For instance, you might have a front-end program that dynamically generates queries where user input is part of the query. It might look like this. This is some C# code where, and I'm not a C# coder, so it will probably look hideous, but this is an example where someone creates a query by concatenating fixed text with input strings. And you will notice in the place where I fill the query string, there is red, purplish, I don't know what color that is, which indicates a string constant, but there's also black, which indicates a variable. If you ever put anything black in a query string, you are at risk. It's that easy to recognize SQL injection black into the query string if you use the default color scheme. If you use a different color scheme, adapt. Black into the query string means something the customer provided goes into your query string. That is unsafe because you can't control what the customer provides. And we then execute it and we basically grant Chris access to do whatever he wants. This same problem can also happen in code you write. If you use sp execute SQL or execute a query, then you can make the same mistake. And again, with the default color scheme in Management Studio, black indicates here is an injection risk. it is again directly visible where the risk is. Frankly, I also think that this is not even easy code with all the quotes that you have to double because of how this works. But there are people who think that this is an easy way to code this. Anyway, this is just as bad. It doesn't come from the front end. It comes from the SQL developer, and it's still dangerous. And while I don't think many people use explicitly prepared SQL, there is also a slide where I show how this same problem can exist if you use prepare, execute, and unprepare, or even if you use prep, exec, and unprepare. That is, I don't think many people do it, but I wanted to include it just in case. All these cases have black in the query string, which means that all these cases can and will be abused by Chris. So all these three have that vulnerability, and that means that as long as there is no criminal, this works. If Chris is legitimate and gives us information, then the query that will be generated and executed looks like this, which is perfectly fine, no problem. And for the record, it will be on one line and without the extra spacing. I used a SQL prompt to improve the layout for readability. If I put it all on one line, it wouldn't fit on the slide. But that spacing is for the SQL Server irrelevant. So this is for readability for you. If Chris is a criminal and tries SQL injection, then what he will enter will be, and I won't bother you with what exactly he has to enter, but if he enters the right thing, he can assure that, yes, he will have to set the email, but then he also inserts a command to set all his crimes to null, and then the dash dash is basically the SQL equivalent of ignore the rest of this form. So the verify email will never be executed. And this is how Chris can abuse this lazy coding. So how do you get around this? And again, with question marks, the very popular method of input cleansing. You simply build extra front-end code to say the user input can't contain an apostrophe, can't contain a double dash, can't contain a whole list of other characters. You will completely forbid all those characters and then you think you're safe. But are you? There are 140,000 characters in the Unicode set. They can be combined. And I know that the documentation doesn't say anything, but are you 100% sure that all of those possible combinations will not run into some unexpected behavior where suddenly the injection works again that you thought you had disabled by cleansing? Are you sure? Because I am sure that criminals are constantly searching for new ways to get around your cleansing. You may forbid 10 characters, they will not rest until they have found that 11th character that you didn't forbid. And they will then be ahead of you because you only notice that after they have wreaked havoc on your system. So this is not a method I like. And by the way, those excluded characters may be valid. Imagine being a billionaire with an Irish name and seeing that you're not allowed to enter your surname at the bank that you want to bank. I would go to a different bank. And you lose an important customer. Or, and I mean, this is a generated screenshot. I will be honest, I generated this screenshot. AI is wonderful. It isn't, but for this kind of task, if you have the patience to attempt it 10 times, it's wonderful. Anyway, I have gotten these kinds of responses. And I looked at them and I was like, oh, cool. So you deliberately reduce the time for a brute force attack from 30 years to 15 minutes. Well, I think I'm going to store my sensitive information somewhere else. Because that's what this does. Every character you forbid reduces the time for a brute force attack exponentially. And you think this makes your system safer, but that's only because you use lazy coding. if you use proper coding, you don't need this. You can allow all those special characters, and every extra character increases the amount of possible passwords exponentially, and so the time for a brute force attack becomes completely impossible, and nobody will ever be able to guess a good generated password. I use a password generator to give myself for every site a random password of all the characters in ASCII, and then 24 of them. Nobody can remember those. I don't need to. I copy and paste from my password manager, and then I go to sites that say stuff like this, and I have to deliberately make my password less safe. I'm sorry, I will get off this, what do you call it? I'm sorry, I will stop nagging about this now, but you notice I get upset by this. And it's not needed. Anyway, let's go to the real fix. And the real fix is once more no user input in the query. That's all. Yes, it is that simple. Nothing more to it. So how do you change your C# code? And you look, what you see is the query string is now completely in dark red. There's no black in there anymore. I think it's also a bit easier. Okay, the price is that now you have to define extra parameters, and that is a bit more work. Some people like to use add with value, but then the code will infer the data type, and that might cause some performance issues. So I like to use the literal add, where you specify the data type. And these are all the changes you need to make. That is how easy it is to make this code safe. Was the difference between the previous version really worth the risk you took? And what about in SQL? Well, it's very similar. You need to declare one extra variable, and again, the code is now entirely in red, and no problems with doubled quotes anymore. So literally easier to read, easier to understand, much easier to type and avoid errors. I like this code better even without the additional safety. And then the safety, of course, makes it very important. We have this params variable added. You need to fill that with a declaration of the parameters and their data types, and then you have to include that when you call sp execute SQL. You can't use this with execute query, so just don't use that. Use sp execute SQL. Much safer. And then, for the people who like to use prepared SQL, and I used prep exec in this example, it's the similar differences. You declare parameters, you have a simpler query, you set the parameters, and you have to add the parameters to sp prep exec or to sp execute if you use that version. And that's all. The bad news. Not all parts of a query can be parameterized. And people want to parameterize everything. Column names, table names, conditions, order by. Either you get a fixed value, the value of the parameter, instead of what you want. So you get, for instance, the column name in every row, or you get an error. So a query like this, you see all the wiggly codes, only select add column is okay. But that's because it will, if you set a column to, for instance, client ID, you will simply get the text client ID in every row and not what you intended. This will not work. And if people tell you, yeah, but I really need in the user interface the ability to select, to specify from what table I select, I really need to be able to change the column list every time, I want the order by to be customizable, all those requests, it becomes tempting to go back to unsafe dynamic SQL, because when you concatenate, the SQL Server doesn't see a variable. If you on your front end or in a stored procedure concatenate the table name after from and then do sp execute SQL, then it will read from table name, and that works, but Chris can abuse it, so you should not do this. And here is the bad news. Now it becomes a bit more work. My preferred solution is to switch to using one query per table with all the relevant columns. Yes, I know normally I say don't send back columns you don't need. Safety first, a bit more network traffic, and then have the client filter out the columns, have the client do the filtering that has to be dynamic, put all the hard-coded filtering still in the query. You still want to minimize network traffic, but one query per table with all the relevant columns, filtering and ordering on the client side. You don't need this dynamic SQL. Yes, it's more work, but you're safe. If this really can't be done, if there's really so much variation in the dynamic requirements, or if people simply insist that it has to be done with dynamic code, then it can still be done safely, but again, with a bit more work. And in that case, what you can do is write a query, and this is just a fragment like this, and this looks incredibly insane because you're just repeating the code. If table is customer, set query plus is customer. And I'm only showing this in SQL. You can of course do the same in your C# code or in any code, but this is the structure. And this is safe because everything that comes into the query is in red. Set query plus is, and then in red, order header. No black into the query, so you can instantly see that it is safe. If you want to avoid a bit of typing, then this alternative will work too. Now we are adding something black into the query. Set query plus is at table. For me, I like this version less because now I have to do more work to check if it's safe. Oh damn, we're putting something black in a query. Has that black thing been vetted? Yes. This is not cleansing where we look at specific columns. This is a delimited list. Only these 3 tables are allowed here. Anything else will generate an error. This is safe. Just as the code above, which is easier to see that it's safe because only red goes into the query string. But both work. Both also mean that if your customer says, oh, I need a 4th table, you need to change the code. If a table is no longer valid, you need to change the code. Because you need to take them out to maintain ultimate safety. Otherwise, people will still use that table. So this is more work. But you have to do that if you want to keep Chris out of your system. Now I'm going to very quickly go about a bit more advanced stuff. I'm not going to go very deep in this. You can find more information on the internet. So far I've talked about protection against outside customers, which is the most important. But sometimes you also need to protect against developers. Not every organization is like this, but there are organizations where there's a deliberate separation of duties. The DBA has certain authorizations. Developers can't have those authorizations. The organization don't want that. The developers are not sufficiently vetted to be trusted with that authorization. And while we normally trust that our developers are good people, otherwise we wouldn't have hired them, we also know that people are people and we should trust but verify. Now many DBAs have maintenance routines that process all databases, all tables, all indexes, even if new tables are added. And those maintenance routines might run in all databases, even in the development databases where the developers do have advanced permissions, because in the development database they are allowed to create their own tables to test their work. The DBA will check them before it goes into production, but in their development database they can play around. And if a developer knows that your maintenance routine processes all tables, for instance for index optimization or statistics rebuild, then they might try to abuse that knowledge. How? Well, and yes, a table like x semicolon exec sp add SRV role member add login name is n quote quote me quote quote comma add role name is n quote quote sysadmin quote quote semicolon dash dash. Yes, SQL Server will accept this as a valid table name. If you use brackets around something, the entire table name is always valid. And now the question is, how is your maintenance routine coded? If it consistently uses quote name, you should be safe. I say should be, because quote name works around all the known problems. But remember those 140,000 Unicode characters? Did Microsoft test quote name with all 140,000? With all combinations of 2 or 3 of them? But it's as safe as you get. But did you use quote name in your code? And perhaps you use standard Microsoft code like SP MS for each table. In the past, there have known to be vulnerabilities in that Microsoft code. I haven't found them myself. I've seen the reports. They have been fixed. Of course, report something like this to Microsoft, they will fix it. But the sad thing is, sometimes when a new version of SQL Server comes out, I once more see reports where someone who has been testing changed or new Microsoft procedures and found a new vulnerability. Sadly, Microsoft makes mistakes here too. So even Microsoft's code can't really be trusted. And if you really want to be certain, always use your own code, or if you use standard code, check the source code. That's it for this video. I hope you liked it. If you do, leave a comment, leave a like. If you have questions, you can put them here. I will try to answer them when I have time. I thank you for your attention and I wish you a great rest of the day. My name is Hugo Cornelis. Thank you for watching. Bye bye.